Hello and welcome. Thank you for joining us for today's IBM Community Webinar. Today, our experts will be discussing automating agile integration. Joining us, we have Kim Clark, who is the integration architect and strategist for IBM. And please be sure to navigate to the IBM community to connect directly with our experts. Without further ado, please welcome Kim.
Hi, my name is Kim Clark. I'm an integration architect working for IBM. My main focus is agile integration, which is a technique used to move integration landscapes forward to enable them to be more nimble, to enable a higher velocity of creation of integrations, more effective administration and operational support of those, and to potentially allow them to be more decentralized. And it's very much focused on a cloud-native approach to performing integration. Normally in my sessions I focus on the architectural aspects of integration, the design patterns, but today I'm actually going to bring things around to product as well, because I think we've made some really significant advances in the IBM integration portfolio over the years, really bringing it towards a more cloud-native approach, and it's a good time to take a look back and see just how big a change that is and just how differently we can perform integration today using the Cloud Pak. The Cloud Pak for integration brings together a huge suite of integration products under the same roof, under the same license, and into a consistent way of working together operationally and in terms of deployment and administration. Whilst you can still run all of the products on the traditional operating systems, there's a huge amount of consistency to be gained by moving to container-based environments, especially Kubernetes, and of course, ideally on Red Hat OpenShift, where we can bring you the greatest value. You'll notice, though, that it's not just integration capabilities that you're seeing on this diagram, and there are a suite of AI and machine learning and automation-related capabilities sitting there too. And so we'll take a look at that in a moment as to how that's being infused into the portfolio. But first, let's take a brief step back and register what's already happened, because for what could be even a decade now, we've been changing the fundamentals of our products to work in a more cloud-native way, introducing runtimes that are more lightweight, have less dependencies, are more able to work in an immutable style in terms of immutable deployment, that focus on concepts like zero trust, and all of these things are embedded into the individual products and also into the broader Cloud Pak for integration capabilities. We're of course constantly looking for new ways to evolve the portfolio and areas to focus on. And the key areas we're looking at the moment are, first of all, around a greater degree of automation in all the different perspectives that means. So in terms of lifecycle and operational automation, as well as moving through into more automated capabilities within integration. Closed loop evolution, which is really about learning from the data we can gather from the way that you're performing integrations, the way your operational environments are performing, and feeding that back to enable us to improve the integration capabilities. And finally, multi-style integration, recognizing that you need multiple tools typically to solve an integration problem. And it's the way that those tools are brought together in a cohesive manner that really makes the difference around your productivity. This is the diagram most people will be familiar with when discussing agile integration. Summarizing it really briefly, on the left-hand side, we see a typical centralized ESB pattern that many customers still have, many hundreds of integrations potentially sitting on a centralized runtime. And then as we move across to the right, we see more and more separation of concerns. The first thing we see is API management being separated out for exposure of APIs as an interface, both within the organization and beyond. And then in the next stage, we see us starting to learn from the concepts of microservices architecture but in the integration space. So breaking up that big silo of integrations into lots of separate discrete integrations or groups of integrations and running them potentially in containers. So we start to see container environments coming in at this point. And then as we move into the final column, we see decentralized ownership of integration. So perhaps integration teams starting to take on responsibility for building and maintaining their own integrations and exposing their own APIs. And on that thought, it's worth taking a closer look at column 3, because something came in column 3. We've noted event management in addition to API management. And this is a relatively new area where we're looking at ways to manage events exposed around the organization and potentially between organizations in the same way as we do APIs today. And if you think about it, that further increases the opportunity for that decoupling between different teams and different parts of the organization. They can start to look at each other, not just through the APIs that one particular team are exposing, but also the events as well. So it's one more thing that they can do from a self-service point of view to be productive. And so let's look at an even further simplified version of that diagram, where we've just got the two transition states, if you like. I've introduced messaging at this level of focus because it's interesting to see that messaging also becomes more fine-grained and can also be running containers and so on. And that's going to become important in some of the examples that we have later. So let's drill down into that centralized ESB topology and see what some of the challenges are. One of the first challenges is that we've got to build a topology, a runtime for that integration, probably an HA pair, right in advance. We've got to build it in the most substantial form to be able to cope with all possible types of integration that we might have in the future. It's coupled with messaging. It's got messaging as part of it, so that makes it much more hard to scale because it's got the persistence of the messaging sitting underneath that as well. And of course, once we put that in place, it's a fixed version, and migrating to a new version is going to be a significant project, affecting all of the integrations that sit on top of it. And then we develop our integrations and ultimately deploy them locally, perhaps to test them, and then up onto these fixed environments where we can't necessarily take advantage of the latest features, and we have to hope that across environments the configuration is identical. Quite often, and understandably, we see quite complex and manual processes required to ensure that we can safely deliver onto these complex environments with other integrations sitting alongside. There's very little opportunity to automate the development lifecycle. Furthermore, there's the challenge that operationally things are going to be done to that live environment that are going to be done to a live running server, and the configuration can potentially drift from one environment to another. So it's very, very difficult to replicate an environment to, for example, get pre-production and production to look exactly the same. And it's quite hard to automate that kind of installation. Agile integration implies much more fine-grained deployment into, for example, containers, small groups of integrations being deployed into an individual container safely, separately from all the other integrations, being deployed with the version of the runtime required for that particular integration, and always carrying with them that same set of binaries and fix packs that they were tested against. It's clear from the blue boxes on the right that this finer grained deployment enables us to deploy more independently and indeed scale these pieces up and down more independently too. But what's perhaps not so obvious is the fact that because we're using container technology, we can automate the life cycle in a much more effective way than we could have done before. And the consistency that the container platform provides allows us to automate the operations as well. And almost hidden from view completely is the fact that we don't have to do an installation of the integration software up front. Let's walk through what really happens when you deploy using containerized technology. So you begin with your integration artifact, could be your message flow, but you also create alongside it a custom resource definition This is just a text file that describes how you want your integration to be deployed. And it explains everything: how many replicas you want, which version of the product binaries you want it to sit against, everything it needs to know in order to be pushed into production. The build process then combines your integration flow with the relevant runtime that you want to run it against, App Connect version 12, whichever fix pack, and so on. And then it's the deployment stage that pushes that into the container platform. So we've now got a fixed image with your mediation flow in it that the operator can deploy, and it uses the instructions from that custom resource definition file to push it into the container platform, knowing, of course, how many replica sets you want, and whether you want the tracing componentry to be set up, and all of those good things. And the operator is appropriately named because ultimately it does what you would do in order to keep an environment running and keep an eye on it. Make sure that the components deployed are healthy. It enables you to upgrade components as well, and it generally makes sure that it's running as you described it in the custom resource definition. Let's have a real look at an example. You might assume that you have to know a lot about OpenShift and containers in order to take part in this wonderful new cloud-native world. Well, what we've tried to do is make the learning curve as easy as possible and give you a view from an App Connect point of view that allows you to deploy a bar file in a very straightforward way. I'll show you later on how we can do much more sophisticated things, but let's just have a look at the simplest possible path to deploying a bar file. If you're working with App Connect in the Cloud Pak for integration, you'll see we have an App Connect dashboard to enable you to work with your integrations without having to work right down at the low-level roots of OpenShift and its console. And in there you can take a look at the integrations that you've got and the servers that they're deployed on. By server here we mean an integration server, an App Connect integration server. And each one of those is running on a container, but you don't really need to know that from this particular perspective. In this example, we're going to deploy an integration that we've already created separately in the toolkit. And we have the bar file downloaded from the toolkit. And in fact, that bar file has actually already been loaded into our repository within Cloud Pak for integration, so we can get it from there. But in fact, as you can see, we could simply drag and drop it into the console here straight from the file system. We then asked if we would like to apply any particular configuration information to this particular deployment of a server. And this is where we could put the specific credentials or certificates required for a particular backend system, for example, that we wanted to communicate with. We're then asked to fill in a form. This form is essentially the details required to fill out that custom resource definition that I mentioned earlier. These are all the details required to decide how your integration is going to be deployed to the server. We can decide things like the version of the runtime that we want the integration to run against, and that's specific to this particular integration. This form is just making it easier for us to fill out that YAML file that we talked about earlier. And this is the exact same YAML file that you would use if you were trying to instantiate this integration using command line tools or by calling an API against OpenShift. There's actually more information in that YAML file at the moment because we chose a t-shirt size, if you remember at the beginning, of what sort of type of server we wanted, and that set some limits for memory and CPU. And we can change those on the form if we change to the advanced settings. And this is where we get to decide how many replicas we want. So compared to a traditional installation where you'd be stuck with the high availability pair that the centralized topology came with, here we could decide, for example, to have 3 replicas, which suits our high availability requirement. And once again, you can see it's just updating that YAML file. So let's go ahead and create that server. And we can see our new server defined there, but it clearly hasn't started. The pods are just starting up. And if you think about what's happening under the covers here, it's just normal Kubernetes. There is a set of pods, 3 pods, based on that replication, and those are starting up, And those could have been created from a normal Kubernetes command line or an OpenShift command line based on the custom resource definition that we had in that YAML file, and then just asking for that to be created by the system. And just slightly speed it up for the purposes of the recording, and we have our integration up and running with 3 replicas. So you've seen the simplest possible path for automating the lifecycle. We'll be onto a more sophisticated one in a moment. But now let's look at another one of our key focus areas, which we mentioned earlier, which is this idea of the closed loop. Container technology enables us to embed good practices into the images that we provide as certified images with the Cloud Pak, and enables us to build the operators that simplify your life when you're doing the deployments of the product. But what if we could go a stage further and actually start to adaptively learn whilst we're working with the product? This is what we're referring to when we talk about closed loop evolution. There are lots of opportunities to gain feedback from anywhere really in the CI/CD process, right the way through to operational data that could give us information about how to help you to build integrations differently, how to deploy them differently, how to operate them more effectively. It's certainly not the first time we've looked at incorporating downstream data to make upstream processes more effective. But what's perhaps different at the moment is the fact that it's become more straightforward to incorporate artificial intelligence and machine learning algorithms to help us make sense of much more complex sets of data, structured and unstructured. And this potentially allows us to make much more sophisticated recommendations on the upstream capabilities. Let's take a quick look at a simple example of incorporating feedback in the design process itself. In our designer tooling, we've been increasing the sophistication of the recommendations given to you to assist you in mapping exercises. This is the beginning of an integration flow in Designer. As you can see, it's listening on a Kafka topic and then parsing the data as a JSON message. We're then going to go on to take that data and map it into a Salesforce data model. And we're going to get that data model from Salesforce by looking at the specific action that we want to perform. And here we're choosing to create a case. And so straight away we can see the case data model drawn back from Salesforce itself. Mapping data fields can be a little bit abstract. So what we're going to use to assist us is a generation of some data based on the fields and trying to guess what kind of data you might see in that type of field. And you'll notice that our map assist function has come up with 3 suggestions based on natural language processing in the background of fields that it believes are the right match. Now it's come up with some obvious matches of name and email, but we'll notice that it's also come up with suggestions for the ones that are less obvious. And you can see the little blue progress stack at the side is giving us a percentage of how sure it is that this is possibly the correct mapping. Now you can imagine normally an integration specialist would have to analyze tens, possibly even hundreds of fields in a complex data model, and here they've been presented with a set of 2 or 3 and some percentages giving them some hints around which ones might be the right ones. So you can imagine the difference in productivity that this can have. Whilst I don't have time to go into it today, you'll notice the FX symbol at the side of the field. That allows you access to a sophisticated set of functions that can perform actions on the text. And that's part of a broader regular expression syntax that allows you to navigate around complex data models and bring together information from different places and allow pretty much any mapping and formatting you might require. So the aim here is to give you a sort of progressive disclosure of more and more sophisticated features as you need them, but the starting point is a very straightforward mapping capability. And so we'll round this example up by performing a test using that generated data to instantly see the effects of the mapping. And you can see from the successful 200 result that it has indeed gone off to Salesforce, created a new case with a new case ID reported there. Another idea which we've brought the first phase of into the product already is the idea of test generation based on operational data. What we've done is introduced into the already quite sophisticated testing and monitoring capability in the API management function within the Cloud Pak for integration, a capability to create brand new tests as part of a project. And it can do that off the back of the Swagger, so off the back of the Open API specification. You can look through the set of operations within there and choose the particular operations that you want to be included in the test, and then it will generate a set of tests for you that it believes would be a valuable exercising of that API. And you can imagine where this is going. We can move forward into the future to start looking operationally at the type of API calls that are being performed and see if the behavior is different to what we would expect for that normal REST API, and then perhaps suggest extra tests that would provide an even more powerful testing suite. Of course, operationally, it's not hard to find things that work in a closed loop style already. Kubernetes, by its nature, is set up to enable changes in the replication strategy of the pods based on the workload. And indeed, we've added to that by enabling things like queue depth-based adjustment to the number of replicas, which is something we brought in using the CADA framework in MQ recently. And we've also got things like the recent introduction of uniform clusters, which enable us to do the same kind of workload distribution that you might see across a set of HTTP-based endpoints with synchronous traffic, to be able to do that with messaging-based traffic as well, so that we can balance the workloads of how many connections are going to which of the different message servers. And we could, of course, look beyond the Cloud Pak for integration at what we're doing in Watson AI Ops, where we're looking at machine learning to help us to understand unstructured and structured data, operational and ticketing information and resolutions, and try and bring that all together to be more predictive about the way that we handle application management. And so finally onto the last of our focus areas around multi-style integration patterns. Most customers I speak to have a wide range of different integration problems that they're trying to solve. And those require different patterns, and those patterns often use several capabilities at once in order to solve a problem. And that's really where our multi-style integration concept comes from. Zooming in on our fine-grained deployment, we can quickly see that there might be integrations that are supported by queues that are exposed over API gateways and talking to other integrations as well. And so whole combinations of things within a single integration problem. And we can add some depth to that by considering the fact that there's a huge amount more to that CI/CD pipeline than I showed in the original example towards the beginning. The build step within the CI/CD pipeline may be doing a lot more than just simply building a container image. It may also be doing a test deployment of that image, performing some tests on it, tearing down those tests as well. And when we add the multi-style element into that, we could be deploying multiple integrations and queues that are all co-joined with one another and need to work in a consistent way. We have an example that we're going to show through a demonstration. Let's just have a look at the business scenario there. So we have an insurance broker that wants to get quotations from 3 different companies. Each of those companies has their own unique way of exposing their quotation system, and so clearly we need some integration capabilities in order to help us get to that data. As a broker, it's their job to find the best quotes for their partners, and they want to be able to make this available over an API so that their partners can build this into their systems. If they can expose those APIs through an API management system, then it will be easier for partners to onboard themselves and self-administer their own use of the APIs. And of course, it will make it easier to potentially monetize those APIs. And they want to be able to amend and deploy and scale all of these integrations and queuing capabilities independently, but they also sometimes need to be able to deploy them together. So this suggests they'll definitely benefit from deploying in a fine-grained way using containers and being able to update things independently and scale them independently. But it also means that they're going to want to be able to deploy a complete system in one go in a consistent way. Because the API needs to be responsive, it needs to respond with as many quotations as possible, as quickly as possible, so that the partners get a good service. And so they're going to have to make all the requests to all of the different downstream companies at the same time in parallel and get the responses back and merge them as quickly as they can. Using queues to fan out those three pieces of work is a nice, easy way to create that parallelism, and it leads to some possible further optimizations later down the line. So even with this relatively simple problem, we've made a case for a fairly complex set of capabilities. So what we've decided to show is how you would go about deploying a complex set of capabilities like that, multiple integrations, queues, and such like. And we're going to use the Tecton pipeline capability that comes as part of OpenShift. So it's one of the benefits of working with the OpenShift environment. And Tecton is a Kubernetes native pipeline capability. As you can see, we've specified a pipeline with multiple tasks that not only builds the individual images, but also deploys them to a test environment, performs some tests, and on successful completion of those, then goes on to deploy them into the next main environment. To make it a bit more realistic, source code is stored in Git. In fact, the demos that we're using here are available in public Git. We've got a fork of that here, and we're going to set up a webhook so that it can trigger our pipeline whenever we make a commit of the code. So our pipeline has been initiated, and we can see on the left-hand side that there are no servers running yet. And I just want to reinforce what that actually means. So there's no running server that we're deploying integrations to. There is no running queue manager that's already been installed that we're deploying queues to. This deployment process is putting those containers in place and starting them up. It's building a brand new topology specifically for this integration right as we watch it building through this pipeline. And now we can see that the dashboard is starting to recognize that those pods are being created. And we're going to speed things up a bit because it's not that interesting watching containers build, but you can see there's a nice diagrammatical representation of the pipeline doing its work all the way through to the testing piece in the middle. And for an integration scenario, we can imagine just how complex this could be. We might be setting up stubs to make calls against in the background. We might be bringing performance test capabilities to push load into the system. And then ultimately we need to tear all of that down before we then go on to the next step of finally evaluating the test results and then deciding whether to push into the target environment. The real beauty of what we're seeing here is that everything about this is the same for each of the different products. So for example, the mechanism used to deploy a queue manager is exactly the same as the mechanism used to deploy an ACE container. And we can edit those custom resource definitions too. So we can change the number of replicas and say move it from 2 to 4. And that provides a to-be state. The underlying Kubernetes infrastructure will now make the changes needed to get it to that new state. And we're going to emulate a failure here by killing one of the pods and watching it come back up again. And we can see Kubernetes and OpenShift doing its job there, just making sure that that state that we've requested is always kept constant. Everything you've seen here is just operating normal Kubernetes commands under the covers. These things could be done against a command line, and they could be done over the Kubernetes APIs. And so we have this consistent mechanism for operating the entire system across all the different capabilities within the Cloud Pak for integration. And once your operators know how to handle Kubernetes and OpenShift, they know how to handle the Cloud Pak for integration. So hopefully that gives you a good feel for how we're focusing our efforts on these three key aspects of automation of lifecycle and operations, closed loop evolution and mechanisms to enable you to be more productive and more efficient, and also coping with those multi-style integrations. One way of looking at it is that we've had to focus on the technology and the architectural aspects for the last few years, but now we're able to start moving up the chain, up the value chain, into how this affects people and processes, and start to enable you to be more effective in your delivery. A lot of customers have taken advantage of our offer to do free integration workshops. Feel free to contact your IBM account rep to find out more about that. We spend time with you understanding your current architecture and mapping you against that sort of progressive landscape that we described towards the beginning. And a very good way of understanding what the steps are that you'd need to take to get to where you want to go. There's plenty of links to resources on the slides through the presentation and a set of them at the end here. And please do feel free to get in touch with me directly should you have any questions about Agile integration or indeed the workshops.
Okay, fantastic. Thank you so much, Kim. And there'll also be a link to the IBM community if you wanted to connect directly with Kim. So that actually brings us over time. So that concludes today's webinar. I just want to thank everyone who could join us around the globe. We hope you guys have a great day. Thanks so much.